Now, the nature of radiation was studied by Rutherford's experiment, in which a simple experiment was demonstrated. A small amount of some radioactive substance was kept in a lead box. Lead box is generally, lead is a substance which absorbs the radiation. It is not letting radiation to go from anywhere else, only the place from where it is open. Okay. A narrow beam of ray emerges from the top of the block, while the radiation coming out of the hole are subjected to an electric field. Here there is an electric field. Okay. The radiation split it up in three parts, as you can see in the diagram. One part bends towards the negative plate, right? This means that this part constitutes alpha particle, because alpha is positive being attracted to the negative side of the plate. Okay, then the other part is bending towards the positive plate. This part constitutes of beta particles. The deflection of beta particles towards the positive plate show that beta are negatively charged particle, as alpha was bending towards the negative, and we could make out that alpha was positively charged particle. The third part is your gamma, which is not bending around any charge, which is neutral by nature. Now, one thing you need to know, that as the alpha particle came out, after a certain distance they are bending towards the negative, but as the beta particles are coming out, quickly they are bending towards the positive. The reason being, from this we can conclude the alpha particle are heavy particle as compared to beta particle. बहुत जल्दी से इनको खींच लिया गया positive की तरफ, but they took their little time to bend towards the negative plate, which proves that alpha particle, किसी भी heavy चीज को खींचने में you'll take more time. So this is proving that alpha particles are heavier than the beta particle. This experiment should be made in this order: alpha particle coming up, bending after a certain distance, beta particle bending very quickly, and gamma particle going straight away. So the third part is unaffected and goes straight without bending. This part constitutes gamma rays. So the gamma rays are uncharged. It has been found that gamma rays are electromagnetic waves, which are also known as photons, of very short wavelength. They are emitted from nucleus that is in the excited state. Now, excited state means when the nucleus is unstable, it is having energy and it has to radiate energy and get a stable state. Okay, so the laws of radioactive decay. First of all, when we are talking about radioactive decay, okay, radioactive decay means that radioactive elements, radioactive rays are coming out of the nucleus, which is in return decaying the atom. Okay, and hence the word radioactive decay. Now, what happens? What changes takes place when alpha, beta, gamma rays are radiated? Let's see. Now, again, a very important concept, that what changes occur when the radioactive rays or radioactive elements are emitted from the nucleus when the nucleus is in excited state. Children, the first is alpha decay, that is when the alpha particle is moving out of the nucleus. Then in that case, this was the initial atom, as we represent the nuclear denotation of the atom. Alpha particle emission, what happens is the atomic number decreases by 2 and the mass number decreases by 4, because a helium particle, alpha particle, a helium particle is being emitted. Helium is 2He4. So finally it is coming out from the nucleus of the initial particle, of the first particle. So finally we are getting a particle in which the atomic number has been decreased by 2 and in mass number it has been decreased by 4, and obviously a lot more energy is released. So for example, if we are saying we are having uranium 238 as mass number, 92 as atomic number, when an alpha particle is emitted, what happens? Atomic number में से 2 गया, 90 बचा, mass number में से 4 गया, 234 गया. We are having helium plus energy. Okay. Similarly, not similarly, But in the case of beta decay, whenever a beta particle is coming out, that is a negative particle or an electron, you know the mass number of electrons is 0, we take it as 0, and the charge on it is -1. So whenever a beta particle is emitted, the atomic number increases by 1 and the mass numbers remains the same. The atomic number, the electron which is having -1 is 0. So this is emitted and we are left with this particle. For example, from a carbon atom, carbon isotope था 6C14. Okay, beta particle was emitted. Atomic number mein we added 1, so we are having 7C and the mass number remains same. So we are getting an isotope of carbon plus the electron and lot of energy. We'll show in the form of equation also. But for gamma particles, when we are saying that when the gamma is being released, then no change takes place in the structure of the atom. It is neutral. So when the gamma particle or a photon is released, there is no change in the mass number, in the atomic number also. So we will be doing some numericals on this later on, in which we have to show the emission of alpha particle and gamma radiations here. And so again I will repeat that whenever a gamma, an alpha particle or a helium particle is being emitted from the nucleus, the mass number jo upar hai will be decreased by 4, atomic number will be decreased by 2. Whenever a beta particle is leaving the nucleus, then the atomic number increases by 1 and the mass number remains the same. When we are talking about the gamma particle, no change occurs in the present state or the first state of the atom. It remains as such.